Good morning or afternoon, ladies and gentlemen. Welcome to Eureka Module 4, Lesson 12. The learning target is I can solve and create fraction word problems involving addition, subtraction, and multiplication. So let's go ahead and take a look at problem 1. Just like yesterday, I'm going to do problem 1, and please follow along with me. These problems can be found in your Eureka problem set. So as you can see here, we are doing lesson 12. So please make sure that you have your Eureka book with you and you are following along. We are going to do problem 1 and problem 2 in this video. So please be ready to follow along and write down what I write. Let's take a look at problem number 1. Problem number 1 says, a baseball team played 32 games and lost 8. Katie was the catcher in 5/8 of the winning games and 1/4 of the losing games. Question A is, what fraction of the games did the team win? So as I'm reading this, I notice that question A is not even asking me about Katie. So I am not worried about when she was catcher, and these fractions are not going to stop me. So first of all, I'm going to draw a tape diagram that represents the games that the team played, because they played 32 games. They lost 8, but I don't know what fraction of the games the team won. So first, for part A, I will draw a tape diagram. And the tape diagram represents all of the games, which in this case is 32. And I'm going to mark off a little spot on the edge for 8. I think that's probably about 8. And these are the games that they lost, although I'm sure they tried very hard. And then I want to find out about the number of games that they won. And then once I find the number of games, I can find the fraction of the games that they won. So I don't know how many they won. So I need to do 32 minus 8 equals, and I'll get 24. So they won 24 games. Let's move on. So if they won 24 games, now I need to find out what fraction of the games this is. So if they won 24 out of 32, I could say that the fraction is 24/32, but that's kind of a big fraction. I don't really understand what that means because the numbers are so big. So we're going to reduce it. And I know that both of these numbers do have some common factors. And the biggest common factor that I can think of is 8. So if I divide both of these numbers by 8, 24/32 is actually equivalent to 3/4. So Katie's team won 3/4 of their games. Now let's take a look at question B. It says, in how many games did Katie play catcher? Well, I know that she played in 2 types of games. She played in games that they won, and she played in games that they lost. And this information is very valuable. She played in 5/8 of the winning games and in 1/4 of the losing games. So first off, to find out the number of games she played in where they won, I need to find out what 5/8 of 32 is. So I'm just going to do 5/8 of, which is times 32. Now, I don't really want to multiply 5 by 32, and then I don't want to divide that by 8. So I'm going to simplify from the denominator. I want to turn this 8 into a 1, so I will divide both the numerator and denominator by 8. 8 divided by 8 is 1. 32 divided by 8 is 4. So 5 times 4 equals 20. So those are the games that she played in where they won. She also played in 1/4 of the games that they lost. And they lost... I messed up. But I'm going to keep on going because I worked too hard on this. Let's cross that out. See what happens, boys and girls, when you don't pay attention. They did not win 32 games. They only played 32 games. So I need to find 5/8 of 24. Get out of here. So again, I'm going to divide both numbers by 8, and I get 1, and here I get 3. Excuse me. She played in 15 games that they won. Now, I also know that she played in 1/4 of the games that they lost. So 1/4 of 8, and I know that I can turn that into a 1 by dividing by 4, and I can turn that into a 2. I know that she played in 2 games that they lost. 15 plus 2 equals 17. Katie played in 17 games altogether as catcher. Let's take a look at problem number 2, and I will make this one go much more smoothly. Problem number 2. In Mrs. Elliott's garden, 1/4 of the flowers are red, 1/4 of them are purple, and 1/5 of the remaining flowers are pink. If there are 128 flowers, how many flowers are pink? So just like in the last one, I'm going to draw myself a tape diagram. I'm going to draw a picture that represents the garden because I just saw a lot of fractions and some numbers, and I saw the word remaining, and I'm a little bit confused. So I am going to separate this out. I'm going to go ahead and I don't even need to worry about my common denominators yet. I'm just going to carve off this number. We will call these flowers red, and that's 1/8. And then I know that 1/4 of them are purple, so I'll carve off this chunk, and I will label those purple, 1/4. Now, this is the amount that's left. These are not the amount that are pink. Only 1/5 of what's left are pink. So I will take this part and I will go 1, 2, 3, 4, and I'm going to bracket that. Only 1/5 of these are pink. And so my task is to find out what fraction of this is pink and how many flowers is that. So if this entire thing is 128 flowers, I didn't leave myself a whole lot of room. This whole thing is 128 flowers. Once I find out how many are red and purple, I can find out how many are left and then find 1/5 of that. So my first task is to find out how many flowers are red. I'm going to do that by finding 1/8 of 128. I'm also going to show my work by finding the purple ones. I want to find out how many are purple. That's 1/4 of 128. So let's get started. This might be a little bit too big for me to do in my head, so I'm just going to do standard algorithm really quickly because this equals 128 eighths, or 128 divided by 8. So I'm going to show my work over here. 128. 8 can go into 12 one time. Subtract. 8 can go into 48 6 times. 6 times 8 is 48. There is no remainder. So I know that there are 16 red flowers. I also don't really want to do 128 divided by 4 in my head. So I will show my standard algorithm, 128 fourths. 4 can go into 12 3 times. My water bottle's rattling on the table. I'm going to move it. My remainder is 8. It goes in 2 times. So I know that there are 32 purple flowers. So if there were 128 flowers and there were 32 purple and 16 red, if I add up 16 and 32, I will get 48. So 48 of the flowers are either red or purple. And so once I subtract this from 128, I will find out how many flowers are left. So 128 minus 48 is 80. So I know that there are 80 flowers left that are not red or purple. So I need to find 1/5 of 80. So let's do 80 divided by 5, and I will get 16. So I know that 16 flowers are pink. Go ahead and try problems 3 and 4 with your team, and I will see you guys after the lesson.